the slake test. And what this does is kind of illustrates how the soil's ability to aggregate together or stick together. And a lot of that is from what Alex has been talking to you about, are those root exudates. So the organic matter within the soil will bind with soil particles, because generally organic matter is positive, or has positive and negative charges both, but the soil is generally negative charged, so they'll stick together. So once those two stick together, then we have decreased raindrop impact, and we have decreased crusting. So usually when slaking occurs, you'll see it even out on the landscape. Once this raindrop bombards the ground and explodes, those soil particles are loose. So then they start to run, and they'll move into these cracks and crevices that you'll see generally in regular, in a lot of clay soils, which you'll have over here in the east, like Alex was saying. Those cracks will fill full of soil, those little soil particles, and then you'll get crusting. So the top of that soil surface, and you'll see that illustrated here in a minute as well, then is so full it won't allow water to go through. So then runoff occurs. So in some instances, when we collect these soil, people call them clods. Some of them are called clods, some are called aggregates. So it just depends upon where you're getting your soil from. All of these soils have come from our Plant Materials Center, which is up north by Manhattan in the Ashland Bottoms. And if you're interested, on September 2nd, they're having their, our cover crop tour. And we just finished planting cover crops here Wednesday. And so we'll have all of our warm season cover crops. Cool season we've already terminated, rolled, and sprayed. But all the warm season cover crops will be growing, actively growing in replicated plots. So you can come and see all of the different species that we have planted, and also how they react in a mix. And what we end up doing with those is sending them to K-State, and we get the carbon and nitrogen ratios. And then they're also clipped for biomass, so that at certain times of the year we know how much biomass is being produced off of each one of those plots. So if you're interested, that's usually it's 10 to noon on September the 2nd. And it's up, if you know where K-State's farm is, it's just up north. If you just Google Kansas Plant Materials Center, I believe it'll get you to the address. So all of these have come from our plots from our previous year. So our first soil, I would call this a clod, comes from our tilled soil. So this has been tilled for decades, years and years and years there at the PMC, because every time they would redo a plot, they would go in and they would completely till. So if, I don't think I have that. I was going to bring that chart and I left it. One of our big posters shows that compacted layer is about 6 inches down. We went around to a lot of the plots and I've run a penetrometer through, which shows you the amount of resistance to the force of the rod being inserted into the soil. And that resistance was peaking at 6 inches. So we know that that's how deep our implement was going. And so then this I would call an aggregate, because this is coming out of our sod fields. So they have a lot of native sod that's planted there. And the butterfly count is coming up here, I believe, next week. So if you're interested in counting butterflies, they'll be doing that at the PMC as well. And I can send that information to Mary, and she can send it out to you all if she has your contact information. I think it's like $3 you have to pay to the National Butterflies something or other. You're volunteering for $3. But anyway, it's pretty cool. Just bring a lunch kind of like, and dress like you are today, and you can count butterflies, because they have a lot of native plots and a lot of forbs, which are those the flowering plants that collect a lot of butterflies. This came off of one of our cowpea plots. And you're going to see something really interesting when we put that in the soil. This clod here comes out of our pea barley plot, so we had a mix in this plot. And then this one come out of a straight Sudan grass plot. So if you guys have hands, I have two. We'll stick them. I lost my hand. No, once I drop it in, you'll see. Okay, so what we do is we place the soil. Yeah, I guess I do. Maybe. No, it'll fall apart. What's happening is, as we place this clod of soil inside the water, all of the air that's inside that clod is rushing out, and all of the water is rushing in to replace that air. What makes it fall apart is if it has a low clay content, if it doesn't have any root exudates that's holding those clods together in the form of an aggregate. Iron and aluminum silicates can cause slaking as well in your soil. Also, another thing that causes slaking is if you have sodic soils, which I don't believe is an issue over here in the east part of the state. So we'll leave these set for a little while, and we'll go ahead and do something else, and then we'll come back to it, and you can see kind of the difference of what's happening. So this one is our tilled, this was our sod, this was the cowpea, this one's our pea barley, and then this one is a straight Sudan grass. Generally, when you're thinking in terms of water quality, yes. You look at the soil that's clear on your left, which would be this tilled soil. It would give you poor water quality. You can see that that's like, this is what's happening when that raindrop hits, things explode, and it just starts to run off. Now, whereas you got this sod, which has been, in sod for decades and decades and decades, there's a lot of roots in there that's holding that together, but there's also a lot of root exudates, those polysaccharides, and they're simple sugars. They're holding all that soil together, just kind of like a glue. There's another component of that soil, which are buscular mycorrhizae fungi, AMF. You'll see that a lot. They sell it for you to sprinkle on your field like magic fairy dust. Depends upon the AMF that you get, because a lot of those are, just like our native plants, a lot of our AMF is native as well. So be very careful when you're looking at buying some of those soil additives. But when those little critters, those little fungi are in the soil, they put out these little branches, kind of like root hairs. They extend that reach of that soil root and help pull in more water. They also bring in phosphorus really rapidly and easily. And so those fungi then are living off of those simple sugars. There is something in the plant that is released, and it's on certain plants, because some of the fungi like certain plants and some of them don't like plants. It depends on what they're putting out as that kind of like a sonar, a little key locator. They know where to go and which ones to associate with. So the ones that are associating, we found is a good association is the cowpeas. We were really surprised at the amount of non-slaking that's very similar to our sod, and this had the pea in with it, but it also has some barley. If I just go through and tap each one of these with an equal amount of pressure, you can see that our Sudan grass is going to start going a little bit more. So just a little bit of disturbance, can cause even more slaking to occur.
Well, you say which one's best. I would say what's be better is start doing a combination of different plants, so that you get different, you engage different microbes with different plants.
Yeah, the more diversity you have in the mix, there's more opportunity for a situation like this sod or this cowpea type. We were really surprised with these cowpeas. Yeah. It's quite amazing.
And like buckwheat, buckwheat attracts a lot of insects, so that, and those insects, they have larvae and stuff in the soil, and, so insects are definitely a part of this, the selection of your plants, too. What we have here is we have a kind of tabletop rainfall demonstrator. What I want you to notice is what's coming out, runoff-wise, and also what's going in these pans. We'll pull these pans when everything's done. But this soil here is no-till with cover crops. They just planted beans into it. It was rye, sunflowers, like a foxtail millet or some sort of millet like that.
How many years been no-till?
It's been no-till for probably over 15 years, I would say. This has been no-till probably since the glaciers or so. No, this is a native grass, came out of a prairie hay meadow. And then this is tilled soil, probably been tilled, I imagine, since for 150 years, I imagine.
So what we're pouring on is about an inch of precip.
Yeah, the rain comes down.
Just for the sake of knowing. Kind of yucky looking precip. What's going on? I'm getting some leakage. There we go.
So, and if you know, the rangeland's already starting to drift through because it has wormholes and stuff. Oh, yeah, this is the, yeah, I'm sorry.
This is mimicking range.
Yeah.
There you go.
Notice how we're already starting to get some ponding on this soil here, and so we're not getting as much coming through the actual pan. So we get kind of puddling effect after probably about the first inch. And the first inch, will soak in pretty good to a dry tilled soil. But after the second and third inch, like we got last night, it'll really start running off.
The more we till, the more we break it down, we release our carbon, we burn everything up. Everybody's been taught, fluff that ground up, tillage, so that you can get a good crop and that the moisture will go in. That's not the case. First inch goes in, after that it's all running off. And now we're collecting it all down at John Redmond and every place else. These are all holding together. Would you rather have your drinking water coming from a field here or here? That's the theory, and that's why there's such a big push for cover crops. No-till, less tillage, keeping your soil covered.
A lot of our cover crop soils, they were tilled previously. So this is just their second year of no-till that they were tilled into.
Yeah,
so initially they were planted to a sun hemp over the entire 30, 40 acres. It was a huge amount of sun hemp. And this is the second year. So these are pretty new. So this would be like, if you were just trying to start out your system. And so you can see that it's just a little bit slower with the Sudan grass. One thing that's really neat about the Sudan grass, though, is the massive amount of worms that I found in that plot is huge, just like the safflower. Safflower is my other favorite plant. It's kind of wicked looking, and it's really a good infiltrating type plant because it has a really good root to it. I don't know forage-wise, they'll probably get to tell us better than me, but I don't think a cow would really want to eat it. Maybe goats. It's a little prickly, but it does bring in a lot of worms, and a lot of that root is pretty, it's a driller. It'll drill right down, kind of like sunflowers, and the infiltration rates that I did in those plots were higher than they were in anywhere else. So that was interesting. But the worms were crazy thick in that Sudan grass. They're good quality indicators, yeah. Usually in native range you'll find about 50 worms per square foot. That's a lot of worms. So we're talking about foot by foot by foot, 50 worms. Just imagine digging up that many. I mean, that'd be a good fishing hole to go to, and you're going to go and get worms. Our conventionally tilled soils generally run about 10 worms per square foot, so it's a little bit lower, quite a lot bit lower. And then when you get into a no-till situation, you'll see around 20 worms per square foot. What those worms are doing are providing castings, and they're very nutrient dense and nutrient rich. So the more worms you have, the more nutrients they're supplying to the soil. Also, they're creating a lot of macropores, those large pore spaces that allow that water to infiltrate down. So they're one of the early indicators of soil health. If you can get your worm population up pretty high, then things are usually plugging along. They're kind of, I wouldn't say if you were looking food chain wise, for like a soil food web, they're not really anywhere in the chain. They're kind of equal opportunity critters. Whereas, we start out with the bacteria and the mycorrhizae fungi, and those are kind of at the bottom of the food chain. So they're the ones supplying all the food for the columbulas, which are the springtails, and for the other, critters that are in the soil. They're eating that bacteria and that fungi and releasing all the nutrients that they're producing. So there is kind of a hierarchy, but worms can go anywhere into that web. A lot of tilled soils, it'll take a couple of years, 2 or 3 years, depending upon rainfall, for those worms, to come in. Usually they're there. They may be deeper because there's about 4 or 5 different species of worms. There's those ones that will travel really deep, and then you have ones that are feeding right on the surface and they're pulling in, the residues off of your surface. If you get your worm numbers up to where they are in native range, you're going to have a hard time keeping your residue on the surface because those worms will take it. They'll pull it down into their dens and feed upon it. So there's a lot of videos on the web you can watch of these worms. In 1 month, They had a foot square. They had 4 different types of worms in this 1 foot square. And in 1 month's time, they completely denuded the top of the soil surface there. They had 2 inches of residue on that surface. And they took all of that, pulled it all down into their dens, ate it, and there was nothing left. So you imagine if you have that on a larger scale and you're removing that amount of surface residue, you're going to have a lot of stuff there to feed them. The whole point of, you know, trying to keep something living and growing on there all the times, trying to feed those. I'm kind of a worm person. I like worms a lot.
I'll show you a little demonstration here. This is a dime. If you guys are familiar with Nrcs or say Farm Service Agency, if we'll let you lose a certain amount of soil and still be in compliance. You heard that before. It's called T. So the T for the average T probably in the state is probably 5 tons of soil. So what 5 tons of soil looks like on your place is losing about a dime a year. So, you know, that looks like not much at all, right? Well, this here is a decade. This is a ½ inch. So that's 10 years. You lose another inch in 20 years. Then, you know, say 30 years, you've lost about 1.5 inches. In 40 years, you've lost, we'll say 2 inches of soil. Probably a lot of fields out there, they're losing more than 5 tons an acre. I would say yesterday we could have lost that pretty easily if we didn't have much cover. And you had to, you know, slope. So, I wouldn't say the government's always looking out for you. I mean, we gotta set a standard somewhere. But I would encourage you to set a higher standard than what we have for just the T loss. So I always kind of wondered what say 5 tons looked like. You know, if we hold 5 tons and put here in the, you know, loaded it right here, you might be kind of surprised how much soil that is.
That's 5 tons per acre.
Yeah.
Multiply that times the acre of your field. How much tons of soil are headed down the creek?
Say we lost 2 inches of soil in 20 years. How long would it take to gain back 1 inch of soil? About 500 to 1,000 years to make 1 inch of soil. But we can actually kind of build that soil back up if we can add more organic matter to the soil, which is a challenge. But anytime you get roots or something in that soil, it can help bring that soil back up.
Many of the farmers we've worked with before, you know, they're out there cleaning their waterways out or whatever. They're collecting the best soil off of their neighbors and putting it on there. So, yeah, one of my no-tillers, he was happy to collect all the erosion off of his neighbors. It was their best soil.